Okay, I'd like to talk about the flood, pre-flood, or the pre-flood flood boundary, the pre-flood flood boundary. And this is an interesting PowerPoint because it was made before PowerPoint. Okay. 20 years ago, did they have PowerPoint? I don't know. Okay, so these graphics are made on a graphics program. They're converted to JPEG, and then they were imported in as image files into PowerPoint to make this PowerPoint. And all of the images that I'm going to show you are film. They were shot. Yeah, 35 millimeter slides. Remember those? Kodachrome. Okay, so it's Kodachrome. Okay, and then the other thing is Kodachrome doesn't work with PowerPoint, so you got to go some intermediate thing. So we scanned the Kodachrome to make digital files out of it, and then that was in there. And some of the files were so big that we could not use a flatbed scanner like graphics that I drew. So we had to take a photograph of the graphic and then digitize it. So anyway, that's, but it's interesting. And then you'll see some images of people you know over 20 years ago. Okay, and I'll see if you can recognize who they are. Okay, okay, the pre-flood boundary. Myself and Kurt were doing field work in Grand Canyon and in Mojave Desert, and so we started talking about this issue of the pre-flood boundary and the pre-flood flood boundary, and so we were thinking about it in Grand Canyon, eastern Mojave Desert. Okay, here's the familiar geologic column. And when you use the words Precambrian or Phanerozoic, you know what those mean. Here's what I mean by it. I don't mean the geologic ages they represent. I mean the strata that occupy that definition or that category. So we have Precambrian strata. Those are strata that are objective and physical, and that's our understanding of their assignment. Not that they represent some geologic age or imaginary Earth picture. And the same thing with Archean Proterozoic. We know they're stratigraphically aligned like that, but we don't have any baggage that we attach to it or need any baggage attached to it. So those are the words. But what the question is, in the stratigraphic succession of the southwestern United States in eastern Mojave Desert and over through into Grand Canyon, where is the pre-flood boundary in that succession of strata and rocks? Okay, and those are great questions to ask. Okay, here's the idea that Kurt and I were talking about back then, 23 years ago, 25 years ago. I think it was 1995 to 97, right in there somewhere.
94, so it's gotta be
okay, before that? Okay, yeah, okay, whatever. Okay, yeah. So it's got to be even before that. Okay, so anyway, history's, okay, so got to be 91. Okay, so it's 25 years ago, it's not 20. Okay, ooh. Okay, well, anyway, we're thinking about what should the pre-flood flood boundary look like, and we thought about the pre-flood Earth, we thought about the creation Earth, and we talked about what the flood would be like, and we came up with 5 of these what we call discontinuities. 5 types of discontinuity would help us define the pre-flood flood boundary. And so an idea of an erosional discontinuity, the idea of an age discontinuity, the idea of a tectonic discontinuity, a sedimentary discontinuity, and a paleontologic discontinuity. And so as we discussed that's the idea boundary criteria, let's call it that way, or discontinuities would be the boundary criteria for the pre-flood flood boundary. What do I mean by an erosional discontinuity? We might expect the beginning of the flood to mark one of the major, if not the major erosional events in the history of the planet. And erosion produces a feature called unconformity. Unconformity, you know what an unconformity is? Okay, so erosion and big erosion, like major erosion, would produce unconformity, which is a stratigraphic feature that might be a primary evidence of the pre-flood flood boundary. And erosional discontinuity might be associated with day 3 of creation week as well. Okay, you might imagine that. Okay, waters be gathered together in one place, let the dry land appear. Okay, the idea of an age discontinuity. Chief in my mind, as I'm thinking about age discontinuity, you might see characteristics of the pre-flood rocks in the first flood rocks. Rocks would be inherited or be assimilated into the flood rocks and retain their character before, and might be indicative of age. Let's give you an example. Quartzite boulders in the Precambrian. There's lots of quartzite in the Precambrian, and that's a metamorphic rock, or partly metamorphic rock, and that's going to be moved and redeposited in the flood, and it would sit above an erosion surface, and so it would imply metamorphic process occurred between when that rock originally formed and when it was redeposited in the early flood. That's the idea of an age discontinuity. And then tectonic discontinuity. Not only would there be erosion, but there might be tectonics associated with the beginning of the flood, especially the beginning of the flood. Why? Because Genesis 7:11 says all the fountains of the great deep were broken up in one day. Okay, and so the beginning of the flood is marked by a colossal tectonic event. And so the tectonics should be imprinted on the earliest flood rocks, and all of the pre-flood rocks should be cross-cut by that. And there's the principle of cross-cutting relationships. Tectonics of the flood should cross-cut the pre-flood. And so that's the idea of a tectonic discontinuity. Sedimentary discontinuity. Okay, before the flood, there might have been ocean floor around and might have been slow and gradual sedimentation, but during the flood, what would happen? The sedimentary process would be greatly accelerated, and so we'd see the character of sediments change across the pre-flood flood boundary. And then paleontologic discontinuity. Not much is going on in the pre-flood world to bury organisms, and so those pre-flood sediments might have very little paleontologic record, because the earth is very good at taphonomically destroying organisms, and so fossilization is not I would not think of as a primary process in the pre-flood ocean. But in the flood ocean, fossilization should occur. So you should see some type of paleontologic discontinuity. And then there may be types of fossils and things that might represent a paleontologic discontinuity, like small fossils like bacteria and maybe bacteria and algae, algal fossils, maybe even pollen and spores, things like that may be represented in the pre-flood, and they may be represented in the flood as well. And so but other types of fossilization, so you have the idea of a paleontologic discontinuity. Here's the erosional discontinuity. It's mechanical. It's not chemical. It's largely mechanical. It's regional, and it's the largest magnitude, and it could have local relief, but has a lot of cross-cutting of underlying units. So that's the thought. So an erosional continuity, the age discontinuity, like conglomerates and breccias in the basal flood deposits, would contain class of underlying formations, even metamorphic class, things like that, which would argue age. And should be the largest magnitude age discontinuity, one of the largest. And so, well, let's do that. And areal extent, thickness, class lithification, class size. You might think about how big this age discontinuity might be. And then the tectonic discontinuity, faults would be cross-cut with unconformity, rapid thickness changes. There could be convolute bedding, convolute being syn sedimentary deformation structures associated with some of these rocks, breccias and conglomerates, which would argue tectonics, and big megaclast. A megaclast is huge rocks, huge blocks. In other words, landslide blocks and things like that, and all kinds of other landslide evidences. So that's the tectonic discontinuity. And then the sedimentary discontinuity, things that would be indicative of catastrophic events preceding or following normal sedimentary events. Okay, so a megasequence, an unconformity bounded unit, finding upward clastics. You can imagine carbonates on the top, multi-formational scale, so we're talking hundreds or even thousands of feet, things like that. So that's the sedimentary discontinuity. The paleontologic discontinuity is change in abundance. Rare to common, okay, change in fossil type, micro to macro, you might think that way, okay, and so those are the boundary criteria. And so we've tried to be rigorous at applying boundary criteria, not just our favorite rock formation or our favorite unconformity. Okay, the pre-flood flood boundary should be defined by these 5 characteristics. Okay, let me share with you the idea or the plot called a paleo geologic cross-section. Have you ever seen a geologic cross-section? You know what a geologic cross-section is? We could draw one through Tennessee from the Mississippi River all the way out to the Appalachian front, and what would we see? We see a deep basin underneath the Mississippi River, and these strata would rise and they'd come up and into the Appalachians and where the rocks have been uplifted. And so you could draw a modern day cross-section through Tennessee. And geologists do that type of thing. But the idea of a paleogeologic cross-section is an interesting concept. And it's a way to show a particular suite of rocks that you're interested in what? Not at the present, but in the past at a particular time. So we're drawing, here's what we think. We might draw some early strata sequences, and we might draw the unconformity on top of a geologic cross-section, a paleogeologic cross-section, be an unconformity. You see the Eureka quartzite over in Nevada? Okay, Eureka quartzite, California, Nevada, and you see this cross-section going across here from eastern California and Death Valley across through just north of Las Vegas into northern Arizona. So here's northern Arizona, here's Nevada, and here's California. The Eureka quartzite has an unconformity underneath it, and we're drawing that flat and level, and the subtypicanu erosion surface all the way across the top of this diagram. That would be associated with middle ordovician, people would call that, okay. So anyway, the Eureka quartzite and that unconformity has all kinds of elevations today, but we can draw it flat in a cross section, and that's what we believe it once was like, or nearly flat, and so we call that a paleogeologic cross section. And so from that surface called datum, the datum being the unconformity at the upper part of the Sauk sequence, or the basal Tippecanoe, sub-Tippecanoe erosion surface, we can hang all of the strata, pile them up as they likely were positioned back then. Okay, yet you see the power of a paleogeologic cross-section. It's an abstraction, yes, but it likely bore some strong resemblance to reality back when it was flat. And so we believe it was flat. So there's a flat surface there, a nearly flat surface and unconformity, and you see how we hang strata underneath it. So there's the Grand Canyon. You can see the Grand Canyon. You can see the great unconformity, and you have the Tapete Sandstone Bright Angel Mojave sitting on top of it. And then you can see the strata, how they thicken off to the west. And also take a look in the Grand Canyon area. There's the Grand Canyon supergroup. That's the Unkar and Chuar strata that begin with the greatest unconformity. You see the greatest unconformity there? Okay, and that thick sequence is what, about 2 miles thick, and then it goes off here. Okay, we're showing the Grand Canyon strata and the Grand Canyon supergroup under the great unconformity in this diagram. We're doing it with vertical exaggeration, 63 times the horizontal. Okay, so paleogeologic cross-section, extreme vertical exaggeration. So those rocks in the Grand Canyon are dipping at 15 degrees, but when we extremely vertically exaggerate it, they look like they're vertical. You see what the effects of that are. And so that illustrates, and that's a convenient way to illustrate these things. And I can show faults on the paleogeologic cross-section. See, there's a fault that comes up and then it's truncated by the great unconformity. So that is cross-cut. That butte fault is cross-cut by the great unconformity. The greatest unconformity comes vertical and then is transected by the great unconformity. The Tapete Sandstone, you see how that works? Okay, what we notice about Grand Canyon strata is the Grand Canyon supergroup is sitting in there, and what is it? It's a rotated block sitting between, associated with this fault. And you imagine the rotation on the fault, and that creates this, maybe two faults, creates the Unkar-Chuar group being in this down-faulted, rotated basin, if you will. Okay, one thing about Grand Canyon Mojave limestone, the Mojave thickens enormously as you go to the west. It's rather thin in eastern Grand Canyon, and then it starts thickening, and the Mojave is very thick out in western Grand Canyon near 14 over here. And then what happens? You pick up a little bit, what's called the Pognip group, Dunbar Shale, Nopah Formation. Those sit above the Bonanza King. So the Bonanza King Formation of Mojave Desert correlates with the Mojave of Grand Canyon. Do you see that, how that works? And there's a thickening, maybe a couple more units out in Mojave Desert. Anyway, Carrara sits underneath Bonanza King, and that is limestone and lots of algal fossils in there, trilobites, and there's a Bisky quartzite, a shale layer underneath it, and then the Wood Canyon Formation. The Wood Canyon Formation looks very much like the Tapete Sandstone, and so we connected up there. there's a little, there's a limey unit here, and that's brings some question. But you see what the paleogeologic cross-section represents. And then underneath here, we have a Sterling quartzite, Johnny, Noonday, and then go into Kingston Peak formation and down into Beck Spring, Dolomite, and then the Crystal Springs quartzite down underneath it. And then underneath that, here's the basement rock. And you can see the basement rock all through it. And in basement, we mean gneisses and schists and that kind of thing. Granite, gneisses, and schists being the basement rock. Is that a convenient way to represent that? I think it's a really good idea to draw one of these paleogeologic cross-sections. It helps us understand the great unconformity, how it goes. Now it's 25 years after I drew this diagram. The only thing I might improve on this diagram is the Wood Canyon formation. I believe there may be an unconformity between the middle and lower Wood Canyon formation, now that I've seen it in the field a lot more. I might draw the great unconformity coming through the lower Wood Canyon formation, this formation, or this unconformity coming up and being truncated or split. And so that, but that's a pretty faithful representation of the sequence. Look at that. We have 8,000 meters, 8 kilometers of strata out in Mojave Desert. And we have less than that in Grand Canyon, of course. And so where do you put the unconformity? Or where do you put the flood, post-flood boundary? Now, here's my, my way of looking at this. I want to look at the Unkar group and the Chuar group very carefully, this faulted mass, and I want to look at that, and then I want to go look at Mojave Desert. So two key areas to look at is the top of the Chuar group, okay, because it sits under the great unconformity and there are flood evidences there, sedimentary evidence of flood. And then the other thing to look at is the Kingston Peak formation. Notice I have an unconformity going into the middle of the Kingston Peak formation. The Beck Springs dolomite underneath it and Crystal Springs quartzite underneath that. So what is that, what's going on there? Okay, so that's where you get field observation. Grand Canyon in northern Arizona, you got the block diagram, and of course we have the great unconformity and the tilted Grand Canyon supergroup underneath, Chuar and Unkar groups. And you can see the granites, there's the granites underneath the Tapete sandstone. Look at the nature of that rolling unconformity. This is 91 Mile Canyon area. It's a topographic high, and that's showing me something about the character of the erosion. And then off to the side, you can see the Tapete sandstone coming off the high areas, and then you see around, associated with the lower part of the Tapete sandstone, these conglomerates. And quartzite boulders are especially abundant. And notice they're not rounded, they're angular, and they're imbricate, and it looks like they've just slumped off areas nearby, and there's the great unconformity under there. So there's the Unkar group, and there is the Tapete sandstone, and that's the great unconformity. You can put your hand, thumb on one rock and your index finger in the other, and what does that represent? That represents the great unconformity right there. It's a surface, a buried surface. And does it represent a billion years missing or whatever? Okay, there's the bottom of the Tapete sandstone. Again, you see the boulders distributed. And so the sedimentary and boulder discontinuity associated with the great unconformity. In the documentary, we went to about the only place we could get the film crew to down in the canyon, and there wasn't a lot of boulder evidence. A little bit, there was a little bit of conglomerate there, but we didn't show that in the documentary, but we showed the nature of the flat surface. And the great unconformity is a big surface there. Okay, you want to think about the top of the the Chuar group here, and we want to think about what these upper strata are like, and so we want to be careful that we know the full stratigraphic sequence. In the sequence, we have what's called the 60-mile formation at the top. I think we took this one because we think we found burrows. This could be ocean floor, pre-flood ocean floor. Okay, here's my explanation of how the flood came over the continent, and there you see the pre-flood basement rock, and you can see the Tapete sandstone, Bright Angel, Mojave. As the Tapete sandstone is deposited on top of the Great Unconformity, there's that scour surface. And so you can imagine in New Mexico, the water coming in and scouring off the surface. Okay, back of the shallow water erosion surface is the place where conglomerate is deposited, and that's the pebble zone. And then offshore, as you go west through Arizona, the Tapete sandstone becomes the dominant, and it has ridges and dune-like forms, small dune forms, and so that represents the onshore and offshore flow. Most of it's offshore flow. So what we do is we think an on-surging flood would create a back surge underneath it. You know what undertow is like? You know, that's on a colossal scale. It's the undertow of the deepening current water over the continent. And the undertow brings the offshore oriented crossbeds in the Tapete sandstone. And then over in Mojave Desert and Nevada, that's where the shale and muds are deposited, even lime mud. And so that represents the Bright Angel Mojave. And so one sequence can explain three different rock types, one transgressive sequence. Unconformity and erosion surface, then pebble, conglomerate, then sandstone, then shale, then limestone in one kind of, I like that type of thinking. Okay, we're out in Nankoweap area, and we're looking at what we think is pre-flood ocean floor, the big biscuit-like algal features that may represent fossils. They would be called fossils, I think, and they're algal-influenced lamination, and they're like big biscuits and big heads, and so maybe that's the pre-flood ocean floor. That's in the Nankoweap area. Here is upturned Precambrian strata, and this area is where we're studying a 60-mile formation. The 60-mile formation sits at the top of the Chuar group. Here's the 60-mile formation, and it's rather thin, but it has enormous current evidences. We were looking at and we're seeing sedimentary evidence of a type of bed form we call anti-dune, which is fast-moving water. And there's pebble conglomerates and that type of thing. A closer look at Nankoweap Butte and the Nankoweap Formation at the top of the Chuar group. And my thinking is this is the first flood rock I can distinguish in the Grand Canyon, right here. And that might be the pre-flood ocean floor underneath, but this is probably some type of gravity flow and strong current. Looking at the 60-mile formation, I think that's the first flood evidence in the Grand Canyon. Kurt and I like thinking that way. Okay, that's 25 years ago. Okay, recognize somebody? Okay, yeah, okay. And there's bed forms in there that indicate strong current. And there's pebbles and things, drops, little, and conglomerates. And look at these breccias, how angular they are. They were hit by tectonic energy and then just distributed by current and not badly eroded. So that's the very angular tectonic breccia associated with the initiation of the flood. In my mind, that would be 60-mile formation. You can see a little more of these very interesting broken layers. And then you see the sandy beds occasionally. More breccia layers, strong breccias, and red sandy matrix. And look at this. There's some type of debris flow there, and there's our coarser beds up there. All that's the 60-mile formation. So I think underneath the Great Unconformity technically is probably where the first flood deposits is, but over the region, the Great Unconformity is the boundary. Okay, California, Mojave Desert. You see what Mojave Desert is, and Death Valley, Panamint Range, that area right there. So going across there, that's where we're studying. So that would be out here where we have this thick strata sequence, enormous thick, 8,000 meters. Okay, 8,000 meters is how many feet? Almost 30,000 feet. Yikes. Okay, that's a lot of strata. So we got to get to know those, and that's the terminology that's usually applied out in Death Valley area. But okay, so I think the first flood I can distinguish by the 5 criteria is the uppermost Chuar group, but directly underneath the unconformity. I think the unconformity goes through here, maybe into the Wood Canyon area, but definitely down below into Kingston. And the Kingston Peak Formation is this colossal tectonic breccia. We're out here looking at it, and we can see giant mountain ranges that have slid. This is Kingston Peak Formation underlying an overlying noonday dolomite over Kingston, and some of these big Beck Spring dolomite class are 1 kilometer long. There's some type of colossal seafloor collapse event associated with the Kingston Peak Formation. And this was mapped by one of my students, and he mapped it and drew a cross-section through it. Evidently, this whole section is a giant gravity collapse feature, and there's huge megaclasts in there. These are sedimentary rocks that have been moved into the sequence. And here's more megaclasts everywhere, megaclast. And look at this megaclast sitting on top of normal sedimentary rock. And then there's a megaclast stacked up against it, some kind of imbricate arrangement. And so that makes the Kingston want to be a big tectonic event. And so that's why I draw the unconformity going down into the middle of the Kingston Peak Formation. The bottom of the Kingston Peak Formation is kind of calm and placid sea. It's thin, thin shaly beds. So that's where I'd put that. Here's more of the Kingston Peak breccias, the breccias out there. I think that marks the first beginning of the flood in that area in Mojave Desert. Underneath that is Johnny Formation. Here's Ediacaran fossil of some type. It looks like a sea pen or something like that. That's found in some of the strata underneath. Maybe that's a pre-flood organism, not buried in the flood. But they're very rare. And then here is again, the Kingston Peak Formation. More breccias. That is the most bizarre breccias I've ever seen. They're just colossal, and it looks like a seafloor collapse event. And we were mapping clasts that were 1 kilometer long. And we have Beck Springs dolomite class in this muddy matrix, and that's the typical Kingston Peak Formation. Look at all the crunched rocks. So Kingston Peak Formation is a submarine landslide deposit. It's underwater, rapid deposition. Oh man, it's not a glacial deposit like some have said. The upper Precambrian diamictites, similar to Kingston Peak, maybe landslide deposits. So that's erosional discontinuity, age discontinuity, tectonic discontinuity, sedimentary discontinuity, and that should be paleontologic discontinuity. We can't edit that because it's not PowerPoint. Maybe the flood boundary. That's what we're thinking. So we're thinking this is the beginning of the flood right here, and it comes down into the thickened, what's called Precambrian sequence underneath the Wood Canyon Formation. So there apparently is a big, thick sequence of what's called Precambrian rock, or strata, under the Wood Canyon Formation, tucked away here, and that represents flood, that sequence there, and then of course the transgression of the flood, initial collapse, and then transgression of the ocean is shown by these two mega sequences. The mega sequence, I'll call that the Mojave sequence, and that can be called the Sauk sequence. And these two sequences mark the beginning of the flood and the transgression of the North American continent. And so from just through that small area, that's the way I sketched that. Okay, so you can imagine this, the day before the flood, maybe something like this. Okay, there's the Pahrump group with the Chuar, Unkar group. Okay, that's what the continental margin looks like. The ocean shoreline is over in New Mexico, say. Okay, and what do we have in Grand Canyon region in Arizona? We have a shallow ocean sitting over Grand Canyon, what's now the Grand Canyon region. And so we have the Chuar group, and that's ocean floor, we think. We have ocean floor evidence, those large balls and stromatolitic structures associated with ocean floor. We have the docks, and we have that type of thing. The Unkar group may be sedimentary strata from Creation Week sitting on the continental basement rock, and mostly Vishnu schist, zoroaster granite in Grand Canyon. And it has faults, maybe a little bit of fault stair step, and it's welded to oceanic crust, you can imagine. And there's the Pahrump group in Death Valley sitting there. And then the ocean deepens into this basin. What happens? Okay, this whole thing gravitationally collapses as the ocean floor is shoved underneath Western North America. And so there you go. And then, of course, these basins form. There's the Chuar, Unkar group basin in Grand Canyon. And so that's the beginning of the flood. Okay, that's the criteria that I've developed and my interpretation of the pre-flood flood boundary. Thank you. Oh, any comments or questions?
When you look at the boundaries and stuff, the sedimentation layer that you assume to be the flood, is it different thicknesses or wherever you go? Or?
Yes. Okay, it really got thick out there in the Mojave Desert, didn't it?
Yeah.
The Kingston Peak Formation was breccias what? And breccia, you know what breccia is? Broken angular rocks that are deposited in a sedimentary situation. Those breccias were huge, over a kilometer thick. Okay, and it, 1,000 meters. Okay, so 3,000 feet thick, a breccia. Now, as we come to the Grand Canyon, those breccias are much reduced, but they're there. So that appears to be one of the best markers of that event. And of course, the tectonics of Scripture is all the fountains of the Great Deep were broken up. Okay, and in a single day, second month, 17th day of the month, 600 years of Noah's life. So that's maybe that's the tectonic signature that you're going to see in the sedimentary rocks. To see how tectonics and sedimentation work together to kind of bring that that thought together. That's and that's been pretty much now we have a lot of agreement among the creation geologists that we're looking at something like that, because you're going out in the field and talking about it a lot, and just, hey, what are other different ways of looking at it? So the breccias and the unconformity seem to mark the best the pre-flood flood boundary.